Good evening, algebra students, and welcome back to Ms. Freema's algebra class. Today we'll be doing day 2 of the quadratic formula. Now, prior to this lesson, we've basically talked about, not every quadratic being factorable and not being able to use the square root method on everyone. So when it's not factorable, we can't use the square root method. What can we use? And we said that was a quadratic formula, where we have x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, we translated that to say x equals the opposite of b plus or minus the square root of the discriminant, alright, all over 2a. Because when you evaluate b squared minus 4ac all over 2a, when you do it all in the fraction, it gets a little chaotic. So, to look at the quadratic formula, the steps to it, we said step 1 was basically to set the quadratic equal to 0. Oops. Don't know what happened there. Now, once we set this equal to 0, what we're basically going to do is gather your A, B, and C. Then we're going to use A, B, and C to evaluate the discriminant. And remember, that is the b squared minus 4ac. Once we evaluate that, then we're going to plug A, A, B, and the discriminant into the quadratic formula. And then finally, the last step is to evaluate the two expressions. What do I mean by that? Remember, you're going to have x equals the opposite of b plus the square root of the discriminant all over 2a. But then your second one, instead of adding, the plus and minus tells us we're going to add it one time, and then we're going to subtract it the second time all over 2a. And this is where we get our two answers. So, let's take a look at a few examples here. So let's go ahead and take a look at a few examples. Okay, the first one down below is 6x squared minus 4x minus 5 equals 0. Now when I look at that, the nice part about it is already in our set equal to 0. So we gather A, we gather B, and we gather C. Once we have A, B, and C, first thing we want to do is evaluate the discriminant, which is the b squared minus 4ac. So, I'm going to replace b with negative 4 squared minus 4 times a is 6, c is negative 5. So when we simplify this, remember, when you square this, it's always going to be equal to a positive. So we get 16. Okay, but remember, a negative times a negative is going to be a positive. 4 times 6 times 5 would be 120. And now, when I do 120 plus 16, I get 136. Now that we have our discriminant of 136, now we're ready to plug everything into the quadratic formula. So x equals, if b is negative 4, remember, it's the opposite of b. So the opposite of negative 4 is positive 4 plus or minus the square root of, what was my value for the discriminant? 136 all over 2 times a is 6. So we're going to replace a with 6. And now we're ready to set up our two answers. Now, what I like to do is write my two equations out. X equals 4 plus the square root of 136 all over 2 times 6 is 12. Then x equals 4 minus the square root of 136 all over 12. And then the calculator does the rest. First, always plug the numerators in independently. So 4 plus the square root of 136. Hit enter. It gives you approximately 15.66. And now I'm going to divide that by 12. And you get approximately 1.3. For the second one, instead of adding now, I'm going to plug this numerator in. 4 minus the square root of 136. I get negative 7.67, or sorry, 66 when it's rounded, divided by 12. But don't put that in the calculator. Go ahead and actually just keep it stored in your calculator. Hit divided by 12, and you get approximately, and this should be approximately, negative 0.64. And these would be your two solutions. Okay, so that's example 1. So in the second example here, okay, when you look at this one, alright, you have 25x squared minus 30x equals negative 9. Uh-oh, this is not set equal to 0, so we have to set it equal to 0 by adding 9 to the right side. That'll eliminate it. Now I want to add 9 to the left side, but I want this to be in standard form. So is it going to go to the left, the middle, or to the right? It would end up being on the right here because it's a constant. So I end up with 25x squared minus 30x plus 9 equals 0. Now I have my A, I have my B, and I have my C. So I'm ready to evaluate the discriminant. So the discriminant equals negative 30 squared minus 4 times 25 times 9. Personally, what I do is just plug it in the calculator exactly the way you see it. Make sure you put the negative 30 in parentheses. Negative 30 squared minus 4 times 25 times 9, and you end up with 0. Well, right away, when the discriminant is equal to 0, right, how many solutions from the discriminant, if the discriminant is equal to 0, how many solutions will there be? There will only be one solution. Now, it makes more sense once we go and evaluate the quadratic formula why we get one solution. So let's look at this. So we're going to plug everything we know into the quadratic formula. X equals, if b is negative 30, the opposite of negative is positive 30. Oops. I don't know why this is disappearing. So x equals positive 30 plus or minus the square root of 0, all divided by 2 times a is 25. That's nothing. Now, think about it. If we do 30 plus 0 or 30 minus 0, both answers will be 30. It doesn't matter because when you add 0, it doesn't change the value. So realistically, if I set both of my equations up, x equals 30 plus the square root of 0 all over 50. Okay, that's plus. Or I do 30 minus the square root of 0 all over 50. Here, my answer would be 30 over 50, which reduces to 3 over 5. And here, I would get 30 over 50, which reduces to 3 over 5. So if you notice, you get the same answer twice. So you only really, if your discriminant is 0, you really only need to evaluate it one time. Okay? So your real answer is just 3 over 5. Now finally, the last example. So Here I look, I have 9x squared minus 5x plus 13 equals 0. This is already good. Step 1, done. Okay, so step 2, find A, B, and C. A is 9, B is negative 5, C is 13. So, discriminant equals, I don't know why this is acting up on me, but negative 5 to the second power minus 4 times 9 times 13. So if I go ahead and I put that in my calculator, negative 5 squared minus 4 times 9 times 13, I get negative 443. What did we say a while ago? If the discriminant is equal to a negative, think about it. If we plug this in to the quadratic formula, we get the opposite of negative 5 is positive 5, plus or minus the square root of negative 443 all over 2 times 9. Remember, you cannot take the square root of a negative number. And this is the reason why there is no real solution. Alright, in Algebra 2 in the future, you guys will figure out, imaginary numbers. But for now, we write no solution. So as soon as you get a discriminant of a negative, just stop. You are done. You can't go any further. So these are the 3 examples. Down below, if I'm not mistaken, you have some examples of your own to do before you get to class. We'll see you tomorrow. Have a good night.